Thanks, everyone. Again, brief intro for those of you just watching online or haven't caught up. My name is Emil, and I am with Collabora. Over the last few years, we've been helping Valve, and at the moment, I'm going to be talking about the other side of the partitioning and SteamDeck setup that we're having, or we've been helping Valve with. In particular, the read-write files. Okay. So let's start with a very brief overview. Obviously, we're going to have a somewhat of a summary of what our requirements are. And when I say our, that's just my understanding of it. So take that with a big grain of salt. And then I'm going to briefly mention some other work of art, or perhaps. And then we're going to explore what the actual partitioning is and how we're managing all those files in a way that's actually sustainable for a device that may have only 64 gigabytes of storage. I believe the top model goes to 512 gigabytes. Then we're going to cover some of the challenges and potential work ahead, either planned or just their crafting. Okay. So let's have a look at the requirements. As you can imagine, atomic images, not much to talk about here apart from the fact that there is obviously an interest, as with any device, to have it fairly robust, and you have a mechanism where you can roll back either systematically or by user interaction or request. Another thing that we need to be aware here is that there is an interest in having both updates and downgrades, meaning that you can get, let's say, from the latest version to the one prior, or if you can, if you're actually running the so-called stable channel, you want to try the beta, which is a little bit newer, and then bounce back. As you can imagine, downgrades are great, but they're a little bit more on the best effort basis. Another thing that we need to be aware is that due to the very nature, as I said, there can be two very different versions. There is a certain interest in having the configuration somewhat separate for each of the operating systems, such that if you end up on, let's say, on beta channel and you completely break up your system, and because you butchered some configuration, you want to be able to just reboot to your normal stable, everything's pristine, everything's sane, and you just carry on. Another thing to consider as well is that while I personally did not sit down and audit, I'm suspecting there might be some information that is leaking across from one operating system to another. Would that be some miscellaneous logs in var or otherwise? So if possible, it would be nice to reduce that. Another thing to consider is, as I said, it's a fairly size-constrained device, or literally, even if you have it on your laptop, you don't want to have the smallest of home partitions. You want to utilize that to the max. You want to consider a certain level of validation. Would that be during upgrades and downgrades, as I said, of the configuration? You don't want, for example, to have a newer system you decide to downgrade and suddenly all these new options that were added for program, let's say, foo, suddenly are no longer accepted, and the program starts crashing because that's the way it's written. And you want to have a certain level of migration, as I said, that ties in with the validation. So, quick look at a few things that I had around. One is OpenWRT. As you maybe know, it's a very long-running project, aimed at routers and networking gear as a whole. Their approach, I'm not quite sure if it classifies as atomic images, but they operate on a single read-only squashfs image. That one is mounted, and on top of that, you have a bunch of overlays, I believe at least one, that allow you a certain level of configurability and installing packages, if you choose to do so. It adds the AB partitioning scheme, so you cannot easily roll back or revert, but it does support to a certain level both up and downgrades. Okay, another one that I had a quick look around is Fedora Silverblue or Kinoite, I believe. I believe the Kinoite is essentially the KD variant of it. And there's a big part here that Fedora as a whole and community behind it is really, really big. And it's one thing to always consider is how they would approach things. So their approach is fairly different. As you can see, you're having read-only user partition, and then you have the var partition, which is obviously read-write, and everything else is essentially a symlink to the var partition. There's a fairly large and extensive list with all the names on their documentation. I recommend going through that. But an important thing to note here is that they're using OS3, which is a fairly different technology and operates in a different way. So essentially, they don't have the different partition sets, but they have a bit of a history of what their prior images were. It also lacks the what I call the OS version configuration. As I said, there, as you update your system, you have a single set of configuration that just evolves and migrates, which may be good or may be bad, depending on your use case. Then I'm going to mention this blog post again, or just this picture at least. In here, we can see the actual partitioning. Single ESP partition that it's not an interest for us. Read-only user partition, some verity partitions, a similar copy, and then we're having a root file system, home, and a swap partition. Okay, let's quickly run through that. As I said, it's a design overview by the systemd developers, I believe Lennart predominantly. I do not know of actual distribution that uses that. I'm happy to be corrected. It obviously uses the AB partitioning scheme, it's atomic based, etc., etc. But there's a couple of interesting parts apart from the configuration files I keep on talking about, is the single, potentially large rootfs, and how exactly does one draw the line? Where's the policy list set? Would that be within the individual, the vendor that sets the systemd reported configuration file, or would that be elsewhere? But the more important part is how do you ensure sufficient utilization of the root file system? Since by default in Etsy you're having just a few megabytes worth of file, but in locations such as var, you can have easily gigabytes worth of data. How do you ensure that the space is there while at the same time not wasting it? Okay, so let's have a quick look at what we did for the SteamDeck. This is the output of ls-block. I'm not sure how easy of that is parsable, but if we have a look, as I said, we're having some ESP EFI partitions at the top that are not of interest. Then we're having a root file system, which is read-only in our case. Let's see what's next in the list. You can see the respective sizes, but they're not so relevant, really. Afterwards, we're having a read-write var partition, which is fairly minimal. As you can see, it operates as essentially a backing storage for Etsy. So we're having the upper directory of the overlay stored in there. This, since obviously we have two var partitions, this allows us this, as a distinction between the different partitions, the different boots A and B. And for bigger things such as, I don't know, Docker images, Flatpaks, core dumps, or whatever, you can see them actually being offloaded in the home partition, which is the very last one. And you can see a bunch of other things being offloaded in there. Obviously, you have the other directories, such as the root and so on and so forth, also being offloaded in there. What's next? Let's have a look. So, quick look at some of the issues or challenges that we've seen. as I said, we are having the upper directory or the user configured changes of the configuration stored in the var partition, which we actually copy upon upgrades and downgrades. That comes with a set of challenges. First and foremost, we need to be careful what we migrate. At the moment, we exclude a couple of files, mostly around the updater itself, to ensure that people at least can update the system, even if they otherwise brick it. There's another issue whereby if the files themselves have, I believe, extended attributes, can cause a little bit of an issue because the upper and lower directory are actually different. The lower directory, which is the root fs, is butterfs, and the upper is ext4. So at the very minimum, it can cause some tooling to produce lots of warnings. Another thing to consider is that a lot of the files are propagated even on a minor timestamp changes, which is a little bit unexpected, in my view, but that's the way it's designed. Another thing I actually forgot to mention in there is that in some cases you may have the expectation that the old and working configuration will be propagated into the new system. But the configuration is pristine such that it's not in the upper directory, so we can actually copy it. So it's not a clear cut what has to be done in a number of cases. And in practice, it's great that we haven't seen that many issues with those. All right. So couple of bits on the work ahead. Oh, I'm going a little bit quicker than I should have. Anyway, so one of the things that we are planning to do in the short term is to have a sort of a block or allow list of what needs to happen, what needs to be copied back and forth. It's going to be a list that end users can augment if they want to. So if you're a person who, for the sake of argument, runs, I don't know, FTP server on your device, if you want to, it's fine. And you have additional packages installed or additional configuration, you can add the respective configuration file to the list. So it actually, as part of the update, everything is seamlessly copied. It's not particularly a clean solution, but I think it's something we can easily go for. Another thing is, apart from this selection list, we can have essentially a copy of what it has not been copied, what has not been migrated, such that people can do that by hand. The second part is somewhat mostly of a convenience factor, because in practical sense, you can just always mount whatever partition, copy everything out, but having it side by side, it's quite nice. Another thing that I was thinking over the last couple of weeks, actually, I never really checked out with the team, is what would it take for us to use the approach that was proposed by Lennart? Would it make sense for us to say, okay, the actual distinction between the OS configuration files is not so significant, or would it make sense? Would it make sense for those changes to be actually isolated in user? Which, in a way, is actually quite nice and good. Just that we need to consider there's a lot of projects out there still explicitly assume only configuration file in etc. So going through the list, as you can imagine, might be a little bit of a time sink. Last but not least, if everything actually proves to be useful and meaningful, how do you migrate from one partition set completely to a different one? Okay, so your read-only file system is fairly fine, but you need to consider obviously the different size requirements, a slightly different layout in the partition table, and so on and so forth. And obviously nobody likes to have the home directory removed, so unless they can prevent it at least. So yeah, In generally, I'm very, very keen on listening, on hearing your feedback on the design that we chose, and if you think there is something different that we can do to improve it in any shape and form. Thank you.
We have a few questions. So, first of all, on your moving files, I mean, the SUSE folks are working a lot on that. I think we should do more cross-collaboration in the UAPI group towards that target. So, yes, we are looking into that stuff.
Yeah, so basically, first comment on the Fedora CoreOS or Fedora Silverblue topic. So with OS tree, what they do is that they also migrate the files in /etc. It's a bit tricky, but basically it means that when you have user changes, then these will stay, but the untouched files from the OS, they will be updated. And so I'm working on Flatcar Container Linux, and that's also like already now with CoreOS Container Linux being started like 10 years ago, using AB partitioning, and they also had the problem that files in etc were outdated and they were not updated. And what we did now this year is that we have a overlay mount for /etc, and that's backed by a lower tier in /usr that has the OS default files that still have to be in etc. And that gives us a way of having user changes in etc that stay there, because that's the upper tier, and in the lower tier things get auto-updated and downgrade works as well and so on. And for /var we assume that the application is able to have compatibility promises that it gives, like for example, when you update your database.
I mean, generally updates are fine. Just if you consider downgrades as a thing that you need to be curious about. Because if your application migrates from configuration or dataset A to B, then it's fine, but they rarely do the inverse.
So in SUSEland, we copied a little bit of what the Fedora Silverlight guys are doing, and then went one step further. So we have a lower dir, an upper dir, and a work dir. So we can tell the difference between, was this a change to the configuration put there by an update? Was the change put there by a user after the update? Blah, 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 blah. So we can figure all that out. Of course, in our case, with all of our atomic updates, we have the luxury of BTRFS being the only file system we support. So all of your other requirements magically get solved just by that. The storage issues all go away because big BTRFS file system, plop it all there, use up the whole disk, and then, you can decide which subvolumes are read-only and which subvolumes are read-write, and handle everything there. So, all your requirements that you had on your first slide, like that's what we do with our transactional update stack.
Okay. Thank you.
There's Lennart first.
I just wanted to briefly mention that in system we actually have a mechanism for doing updates, like if your /user is updated and then etc is old. It's called condition needs update, and everything it does basically it compares a timestamp of the top level /user directory with the same thing in etc, and it's supposed to do something like, for example, run ld config and things like that. But it could be used for basically anything that needs to process old configuration files into new, and it's supposed to be it's not going to be your solution because you want multiple rollback and things like that. But I'm just mentioning this, that there is a basic concept there. Not sure how many people use it, but it's
actually a few weeks ago I discovered that the hard way when there was people doing downgrades, and it turns out that the updated timestamp was preserved as opposed to being removed, and they ended up being with completely different LD config cache, and it was even more interesting because the config cache itself was presenting one data set and running the LD command was presenting another. It was an interesting experience, but yeah.
Yeah. So I wanted to mention that you said that on overlay, when you change the timestamp, you copy the whole file.
Yeah.
If you are constrained, the kernel module takes a parameter that is called metacopy, and you can disable that.
Nice.
And you only copy the inode, so you save space and. and it's faster.
I don't think the space is a concern, but copying it when it's actually modified, that's actually better. So, metadata, thank you.
So with macOS and transaction update, if we do a rollback, which includes etc.
Sorry, can you speak closer to the mic?
Better? So with macOS and transaction update, if we do a rollback, then we roll back etc too. So your problem with the config cache and everything does not exist if you do a rollback of the config files too. So if you do a rollback and you have outdated config files in etc, then your rollback is not complete, only partial. So and we solved that with several overlays matching the snapshots to which we roll back.
Okay.
So I have a question regarding use cases for this and what you talked about in your previous talk.
Yeah.
You mentioned SteamDeck on multiple occasions. So is the motivation behind this and previous talk sort of like at the end of the day to have sort of like a reference architecture for something which is not built on OS tree and it's unlike Silverblue, but at the same time solves a lot of similar problems, but it uses A/B partitioning strictly?
I mean, the use case for those is I've been working on those. I saw some problems. I came here for feedback. That's the use case. I mean, I'm presenting the problem as I see it. It's not about making anything big or grand, but as I said, it's kind of immediate issues that I foresee.
Okay.
Certain programs have very large config files in exec that a user might only change a very small part of.
Yep.
So one that comes to mind immediately is SSH. Is there any provision for layering where only a part of the file is changed?
Unfortunately, no. Or was it like
Solution is drop-ins, yes. Any other? Yes.
So more for the last question about SSH and config files. You don't need to edit the config file from SSH because it supports a dot directory where it includes only snippets, and if you only change your one single option, then you don't need to care about the rest and the update problem is solved. So that's why at SUSE we use user etc SSH for the config from the distributor, and etc only contains the single snippets of the user which then overrides the single option. And all your problems are solved with that. And we try to do that for even much more software.
I mean, this is, I believe Lennart also blogged a post about this, the stateless systems. And in my personal time, I've been going around random projects saying, hey, can you adopt this? Here are some patches. But as you can imagine, it's a bit of a one-man fight. So it's quite a lot of projects out there that need to be updated. So
we should make a list of base things that make up the base of common OSs like SUSE, Debian, and whatnot, and work to it. Well, it's a lot of work.
It's different bases for different use cases. So.
Yeah, I know. But the software, the core stuff is always the same across all distros, right? So, yeah. But anyway, more questions or comments? Are we doing time? Yes. We still have time for one last question.
It's more of a note, really, but the configuration issue. I found that if I think it's Small Step or Ori, one of those are doing like confx, so they're doing their library where they do everything, and they support environments, they sort drop theirs and stuff, and they include that and do nothing in their own project. I think it makes sense to really can we just say how we do stuff so Prometheus doesn't no, you shouldn't do environment expansions. Okay. But that doesn't work with systemd. So, but I mean, hopefully in a world we can have it works the same. You can do the same.
Yeah.
So I think that's something we should aim for, maybe.
Yeah. Well, it's been on my to-do list to actually bring up Arch Linux RFC, where like the Arch development team actually either starts hacking on those locally, or we start springing out with respective upstream projects. But time is limited.
And actually, on your point, we should write a spec for that. And I tried to get the change into XDG, didn't work out. So we'll have a separate specification for how to do configuration with entropes and so on in the UPI group GitHub pages. I will add it there. I tried to XDG, didn't work out, unfortunately. So we do it like that. And I think, yes, we are out of time. So let's thank the speaker.
Thank you.